Alright, in this video we'll first review a few key things about exponents and then look at question 6 on the worksheet. So here are a few properties of exponents that we're going to need to know from time to time. So if I take an exponential expression like a to the n and multiply it with a to the m, I can add these exponents to get a to the n plus m. So something like a squared times a cubed. Well, I have two factors of a here and another three factors here, so you have a total of 2 plus 3 is 5 factors. Okay, now if you divide two expressions like that, you're going to subtract the exponents. And here's an illustration of why that's the case. So I have something like a to the fifth over a cubed. So 5 factors of a on top, 3 on bottom. You're going to get 3 of those factors to divide out, leaving you with, well, 5 minus 3, which is 2 factors left over. Okay. You have something like a to the n raised to the m power, then these exponents will multiply. So something like a cubed squared, well, squaring just says multiply a cubed by itself, and then a cubed times a cubed by this property up here would say a to the 3 plus 3 is 6. Or put another way, you're just really taking 2 of the 3's. You're multiplying those exponents to get the 6. Now negative exponents, I'll say a little bit more about those down here in a moment, but essentially what they do is they act as as reciprocals. So if I see something like a to the minus n, okay, then the negative is telling you, okay, flip the exponential expression over, and then that exponent will become positive. So something like 2 to the minus third, you reciprocate, and you'll get 1 over 2 cubed, and 2 cubed is 8. So all in all, you would get an eighth. And then if I had something like 1 over a raised to the minus n power, then reciprocating 1 over a would just give you a, and then that would be raised to the n power. And here's an illustration of that. 1/3 of the negative x, you're going to get a 3 from the reciprocal, and then that's getting raised to the x power. Alright, so now for negative exponents, why exactly do they act as reciprocals? Well, here is an example just to illustrate why. So if I have, say, 2 to the fourth, right, this is 16, 2 to the third is 8, then it goes to 4, then to 2, and I'll stop there for the moment. But what are we doing as we go from one of these values to the next? Well, I'm just repeatedly taking half. Okay, so to continue the pattern then, I'm just going to continue taking half. Okay, so what then will the rest of these values start to look like? Well, for 2 to the 0, I'm going to take half of 2, and half of 2 is 1. Okay, so that's an explanation as to why something to the 0 power is 1. There's nothing special about the base 2 here. You could apply the same argument to any base, but we do have, I'll add it to the list here, a raised to the 0 power is 1 there, as long as the base a is not 0 itself. Alright, so then continuing on, okay, now for 2 to the negative first, what am I going to do? I'm going to take half of 1. So that's going to give me 1 over 2. So 2 to the negative first power is saying take the reciprocal of 2. Okay, now what am I going to do? I'm going to take half of a half. Oh, that's a quarter. And what am I really doing there? I'm taking a reciprocal and I'm squaring. So flip it over and square, you get a quarter. Take a half again, you'll get an eighth, so on and so forth. Flip it over and cube, right? And that's what we were saying up here. Alright, so that's where those patterns come from. Let's now look at question 6 on the worksheet here. We have to simplify each expression using properties of exponents. So in part A, I have 1/3 to the negative x. Oh, and that's just that same example I had on the previous slide. So I'm going to take the reciprocal. That's going to give me a 3, and then just raise that to the x power. That's it. Something like b, 16 times 2 to the x. Well, 16 is 2 to the 4th power, and I'm multiplying that with 2 to the x. So notice here I can combine those as one exponential expression. That'd be 2 to the 4 plus x. All right. How about 81 times 1/3 to the negative x plus 2 power? Okay, a little messier here, but one way I could start this is to break this thing up, the 1/3 to the minus x plus 2. So I could take this and I could split it up as 1/3 to the negative x times 1/3 squared. Okay, so what is that going to give us? It's going to give us, well, I have the 81 out front, and then I'm going to have a 1/3 to the negative x. Oh, 1/3 to the negative x is just 3 to the x, and then I have 1/3 squared. 1/3 times 1/3 is 1/9. Ah, okay, so now notice the 81 and the 9, I can simplify there, divide out the factor of 9, so I'm getting there, and now notice, hey, 9 is 3 squared, and so now I can combine as 3 to the 2 plus x. Okay, so a little more complicated there. This, by the way, is certainly not the only way you could approach that. You could, for example, have written 81 as 3 to the 4th power and then proceeded from there. But this is a way to do it. All right, and then we have d here, 5 to the x plus 7 power divided by 125. Well, I'll start by writing the 125 as 5 cubed. And now, since the bases here are the same, that property of exponents on the previous slide said, hey, now I'm going to subtract the exponents. So x plus 7 minus 3. So that'd give you 5 to the x plus 7 minus 3 would be x plus 4. And that is going to do it. And that's it for that question. Thanks.